So, hello friends, hope you are doing well. So, today, the purpose of this objective of this particular video is that we are going to read multiple PDFs from the local drive. We will tokenize the thing and store it into the vector database. And of course, thereafter, we are going to create the retrieval to retrieve the search query result from the vector database. And later on, whatever the data is being written by the retrieval from the vector database, we are going to use the OpenAI to generate a formulate question answer. So that's a very brief overview or heads up for the total video that we are going to discuss, and it will be very short, crisp, and concise. So I'm not going to talk what is a RAG, what is the QA generation. So that's a very different topic altogether, and we can discuss in another video with a more detailed approach. But for now, let's focus the tasks in our hand. So this is my notebook. It is already open for you, and the purpose is clearly written. So this segment we are dealing with read the PDF file from the directory, then do the RAG. Okay, I use LangChain and then OpenAI to generate the question answer. So these are the small steps we have been written over here, and I will share the this particular notebook to the source repositories to the GitHub so that you can download and you can review it also. Okay, so now going over the video. The first part is to read the PDF, store it in the Chroma DB. So for the vector database purpose, right now for today's video, we are using the Chroma DB and to get the retriever to get the question answer. Okay, so I'm not wasting my time to write the code in the in this notebook, pattern notebook, and run in front of you, because that will cause much more time, and we don't have much time over here. So this discussion is all about the concept. So as you know that we need to import some few libraries over here. So the libraries that I will need from LangChain I have written over here, and all that you need to have your OpenAI key over here. So insert your OpenAI key to gateway. Okay, so just run this particular cell, and there are a couple of things that that you may use. I'm using the OpenAI embedding for the token generation purposes. Okay, but you can definitely use the HuggingFace embedding also. So you can try it one time OpenAI embedding, and thereafter going for the HuggingFace embedding. See the result. Okay, so let me run the first particular cell over here. So it's run. Now coming to this particular function. Okay, so this is a function which I have written. Actually, the purpose, you see, I get Chroma. So actually, what is happening? It has a two parameter. Okay, the path of the directory in the Windows folder. I'm working on Windows. So where my PDFs are located. Okay, so today I have two PDF with me, which are two PDF book on Python actually itself. So I have stored the PDF. I will show it. Okay, so in this function we have to pass the directory path where we are going to retrieve the PDF. That's the first parameter. Okay, and the second parameter is the collection name. So obviously Chroma DB is a vector database. So if you want to read the data from the PDF, so we want to store it in the collection. So it can be in memory. So if you are working on the in memories, then you don't need to specify any kind of collection name. Okay, but my objective is to store the data in the hard disk actually. So that is why it's a persistent database for me. So these are many advantages actually, because we will be reading a lot of PDF. So as the memory goes out actually, so that's why we are going to save the data in our local hard drive also in the Chroma database. So I will demonstrate that step. So this is a fairly simple code. So what exactly it is doing? It is getting the PDF DIR, means the directory path of the PDF files. Then obviously we are creating a kind of list over here, document. Okay. Now in this code, what is happening that it is going into the folder. Okay, as you see, the files in the OSL folder path. So it is reading the each and every PDF from the folder path that we are specifying over here. Okay, and thereafter it is searching for the file which ends with the extension of .pdf, obviously. Okay, now it is creating the main path over here. Then it is taking one particular library from Python, that is the PDF loader. If you see in the import section, you will see that we are importing this particular library to read load and read our PDF. So here it is executing loader. Okay, so now after that loader.load, it is loading the PDF, and it is just pushing the collection into this particular document list. Okay, now after that, what is exactly happening in this line, as you see that we are going for the characters text splitter, because your text is coming as a normal text, as stream of text. So for storing into the vector database, we need to divide it into a chunk size. Means I'm getting a chunk size of 1000 and chunk overlap of 10. So actually what is happening, we are dividing the string into a chunk of data. Okay, and by the help of the characters text splitter over here, and thereafter we are creating the chunk document over here. Okay, by the split document function. Now once the all the PDF has been loaded, all the chunks of the document has been created, because these chunks needed to be stored in the vector database. Okay, that is the whole purpose of it. Now we are writing a statement just to understand when the the chunk has been created and our load is complete, so that we can target our vector database Chroma DB to store our data. So in this line, we are creating the Chroma DB client. Okay, and see, we are passing this particular collection name here. So obviously we are creating the collection. So my collection name is Python. It's fairly simple, and it is your collection. And now so the collection has been created. So this particular method in the Chroma DB, actually what happened, get or create collection means, it means that if you give a name of the collection, if it is existing, it will not create, but if it is not existing, then this particular Chroma DB, this particular function get or create collection, as you see the definition is here. Okay, it will create a new collection for you if it is not existing already in your Chroma DB that you are targeting. Okay, now we are now so as you see in this particular step, all the chunks, it's a list of document. As you see, if I touched over here, it says this chunk means the string has been converted to the list of document. It's a document chunk. Okay, now we cannot directly store this chunk to the vector database, because vector database needs an embedding. Okay, so it's not a normal the traditional database at all. So it stores the data vector space in a numerical format, and it's kind of it's storing the data in a vector database in the vector space, and the space location, it can be n-dimensional actually, and the location is pointed out by some numeric values. Okay, that is what exactly the embedding is. Okay, so we are asking the OpenAI to give us the embedding over here. Okay, now so we are taking the help of the OpenAI embedding. Okay, so that our list of document, means the chunk data, can be embedded and pushed back to the vector database, that is our Chroma DB. So in the very next step, what is happening over here, we are calling a method called from document for the Chroma DB. Okay, now this this particular method will, what exactly it will do, it has some parameters. As you see, in the first parameter is a document, list of documents. So it is asking that if you are calling me, then give me the list of document that I want to push, or I will embed that by your embedding, whatever embedding you are supplying to me. It is in the second parameter, as you see, that embedding equal to embedding. Okay, so you need to give the embedding. So the purpose is that it will take the list of document, embed it by the embedding function that you are providing in the very early step. Okay, and it will, so here this particular section, persist directory, it not necessarily every time. So as I told you that if you are working on the in memory, then you can omit this particular line, okay? But I will save it this particular vector database to my local hard drive. That is why I am specifying the location of the persistent directory, okay? Now I am also giving the collection name that user has passed over here, okay? So it will create the collection for me. Now after that, see, from document, if you touch this particular method from document, you will see that after creating the collection in a particular Chroma DB, it is returning back you the Chroma DB. Okay, so that is our vector database. So Chroma DB is kind of vector database. So after creating the collection in the particular Chroma DB, it is returning back us to the Chroma DB, and we are also returning back the same Chroma DB from the function. As you see, I have typecasted the return type to Chroma. Hope this explanation is very much clear to you. Now let me show you, the folder location where all the files has been. I am putting all the files. Okay. So if you come down to the next line, as you see, my directory path is d dot. Okay. So let me show you how does it look like. Just give me 1 minute. Okay. I will just show you that. Okay. So as you see, this is my D drive. In the document folder, I have 4 Python PDF books over here. So it's vary in the size actually. So this is my source location from where my program is going to hit and read the file from this particular area. Okay. Now this is one part. So let us first run this particular program so that it can read. But of course you remember you have to pass your OpenAI key over here. Okay, without that it will not work. I hope that I am making sense, because in this line we are using the OpenAI embedding. Okay, so without this OpenAI key, this particular line will not execute. Okay, and I have commented out the HuggingFace embedding also over here. So you can you just comment it out the OpenAI embedding, and you can open up the HuggingFace embedding also, just for the testing purposes. You can do it by yourself, not an issue. Okay, so let us give our OpenAI key. I will give my OpenAI key. I will just execute that path. Okay, so okay, so let us execute this particular customized function that I have written. Okay, now it executed. Now this particular line, we are calling this particular function with the PDF layer that I have been I already shown to you, where my all Python books are there, 4 books are there. So I will be reading those Python books, and I am giving a collection name of Python. Okay. So let's try to run it. It will take some time actually. So let me clear up all the outputs first. Okay, let's run it. So as your data grows on, you have more MBs to be read actually. So it takes some time, not that much time, but it will take. So we have to wait for this to be loaded up. Okay. So you see, it has not touched this particular line yet, means where I have written print.load, means the load is completed. Still it is loading all the things. Okay, now after 40 seconds or so, the load is done. Means it executed this particular line. So all the chunk of the document from the PDF, so the list of the document has been created. Now it is pushing, embedding the docs and try to create this particular collection, and over the collection it will try to push the our embedded data into this particular Chroma vector database. So it will also takes it's all depend upon your from where the workstation of you, what is the capacity of your workstations. So we have to wait. So for now, let's discuss a few more things without wasting the time. Let it be loaded. It will be shown over here. So okay, it's done. Okay, it's almost 1 minute 36 seconds. It took to load to this particular Chroma TV. Now, so we have load embed all our data and push it to the vector database, that is our Chroma TV. Okay. So if you touch over here, it will say that it's a Chroma TV. Now the question is that how we are going to get the data back from the vector database. So it's not a normal search at all. So our search query also needed to be embedded by the same embedding that we have used to store the data. So to facilitate this purpose, Chroma TV has a method, not Chroma TV, rather LangChain give us a method that if you call this as retrieval, it is give you the retrieval object. Okay. So this retrieval object, once you have that, if you pass a query, it will automatically embed this particular query. Means let's say we are executing over here, we are getting a retrieval. Okay. So the purpose of the retrieval is that whenever you pass a query in a retrieval.invoke, so you are invoking, asking a query, it will automatically embed the query, hit the database from where the retrieval has been created, okay, and search in the vector space for the similarity. Okay, so it's always similarity search. So key neighbor search, you can specify also how much neighbor how much data you want to retrieve from a vector database also. Okay, so that is the purpose of the retrieval. So now what we need to do is that you have to write a query. So my query is very simple. I am asking the vector database what is the function in Python. Okay, it's very simple. Okay, now remember I have 4 books, right? So I can have 10, 20, many books over there. So my target is that just to find this particular answer. Okay. Now this is called rank. Now let us try to execute it. Okay, and it's fairly simple. Nothing here is that much complicated. As you see, it instantly return. See the although I don't have a much faster workstation available with me. Okay, but still see how fast its query goes over there and it gives us a result back. So I know this result, it cannot be viewed totally in this particular, window. Okay. So that is why what exactly I am doing is that after getting the result, and you see the result is also list of the document. If you remember when we are getting the data from the PDF and we try to push it back to the Chroma TV, actually we get the chunk of data. It's called it's a, if you got the type, actually it is the list of the document. So we are pushing the list of the document, it goes on the embedding part, storing the vector database. Now we are running a query. Okay, the retrieval is again doing the magic. It is converting, it is tokenize your query. Okay, and it is generating a list of document. Now it is asking the Chroma TV to find the nearest match, okay, in the vector space. After getting the result back, it is also returning you the list of document, okay, the nearest match for your query what you have been specified. So just to show you what the result is actually containing, what I have done over here, that as you see, this is a list of document, right? So what I have done over here is that I have created one particular list dictionary, and I have taken, if you see that it has a tag page content. Okay, so now I am converting this to an HTML file so that I can show you what exactly has been retrieved by the retriever for your query. Okay, so if I just run it, it will create an HTML file over here. Okay, now if I show you the HTML file, it will be rag HTML. Okay, So here is the file. So let me open up the file in the browser itself so that I can easily show to you. Okay. So this is the result, end result that we are getting. Okay. So now you see that what was our question? Our question was like this: what is the function in Python, right? So we targeted the word function. Okay. Now see why this document has been returned to us. Okay. Now you see, if you go to the right side, you will see that it is getting the word from this PDF and this PDF. Okay. So if you search over here, you see why it is retrieving the document for you. Okay. And it is also specifying the page from where it has fetched the data. Okay. It's a similarity match. Now if you change your query to something else, let's say we are querying for the lambda. Okay. Now we don't need to create the PDF database anymore because it is already created. As I told you that I am storing the my Chroma DB in a collection where my Chroma LP exists over this particular location. So it's a persistent DB. So I don't need to run if I change my query, so I don't need to run this particular functionality to read the PDF one more time. It is not needed. Okay. Until unless your PDF location has some changes. Okay. So maybe you are adding one more PDF, so you may need to run it to load the new PDF in the vector database. So I have changed my query. Now my query is the what is the lambda. So if you are from any programming language like C# or Python, you definitely know what is the purpose of the lambda function. Okay. So let us run it. Okay. Now you see it's written as a different result, and I know it is not visible over here. Let me put it in a same HTML file and try to show you. If I refresh it, you see now the result has been changed, and so it is taking the data. Now if you search for the keyword and it is taking the data, you see it is taking the data from a different PDF altogether. Okay, so it has a match in this particular PDF. The PDF has been changed actually. Okay. Now if you go for the word lambda, you will see that. So that is why it is picking up this particular chunk of document. You remember the chunk of document that we are storing in the vector database, right? So the metadata means from where this is the PDF file from where the data has been fetched out. Okay, for the similarity match here with lambda. And this is the page number from where it is getting the data. Okay. Now, let us do one more thing. Okay. So our retriever has successfully retrieved the data and it has been represented over here. Okay. That is what I know. What is the purpose of the retriever? To retrieve the result of a search query. Okay. Now, what exactly we are going to do? See, this is not a at all a human readable message. So, if you are looking for just a RAG, just to search the particular keywords from your PDF files, so your journey ends up over here. But really, is it a human readable format? It's absolutely not. So we want fantastic answer based on our PDF, right? So for that particular purpose, we have to use the large language model. So the purpose of this is that our RAG journey ends over here. RAG is what exactly the RAG is doing actually. It is taking the data from our local database. Okay, it is searching to the vector database. It is generating the answer for us or the similarity vector search for us, list of document. Now we need to pass this list of document to our LLM model as a context and ask the LLM to give the answer based on the context. Okay, so that is what now this new section is coming up. Now we will use chain, means LangChain chain and large language model. I am using OpenAI right now with me to give us the output of the RAG, means the RAG will be used as an input or context to the LLM, and LLM will see the context or and try to give us a also see the question what user has been asked, and it will formulate by the context and the question the appropriate answer for the question. Okay, so for that purpose, now over here, so one more point over here is that let us assume, because I am dividing this section in two ways, there is a primary reason behind it. Okay, so it can be like that, you load your PDF in a vector database, you perform, some kind of RAG, this question answer just to test whether, your PDF has been loaded in the collection and it is returning back, the result of your search query. So maybe one day your journey ends over here. Now, the question is that after 2 days, you may want to, ask the vector database some kind of question. Okay, so you are not going to recreate the vector database and load the PDF one more time. It's not like that. Okay, the vector database is already on your hard disk. So now the purpose has become is that we need to use the particular vector database that is already present with us in our hard drive, and we will try to load the data from the vector database. Okay, so as you see in this particular line, I am using two particular libraries, few particular libraries over here. For the Chroma section, I am using LangChain Chroma, so import the Chroma, and also I am using the ChromaDB itself. Okay, it is not for the LangChain. So if you go to the ChromaDB site, you can install the Python libraries. Okay, why I am using these, because it has a particular purpose. Actually, it is not related to our workflow, but just to show you one particular thing. Okay, so let me run this particular thing. So I will come to this section one by one. First, let's understand why I am using this particular ChromaDB. So it's like that, I want to see whether my collection is already stored in this location or not. Okay, so now I am creating a client for this ChromaDB, persistent client, and I am specifying the path of the ChromaDB. Okay, so I am asking to return me back the list of the collections that the ChromaDB has. Now you see that this collection name Python already exists, means we have successfully created our collection in the previous step. So that's the evidence. So if you don't want that, you can exclude this input ChromaDB over here and you don't have to execute that thing. Okay. Now, what exactly we are going to do, that as you remember that I have told you that, so we are starting, let's assume we are starting our journey in the second day. Okay, so we created our vector database, we search in the RAG, we confirm that the collection exists, and we finish our journey. Okay, now in the second day when we are coming to the picture, what exactly we are trying to do, we are trying to get the retrieval from the same Chroma database. So obviously we have to use the same embedding that we used when we insert the data in the vector database. Now we are going to retrieve it. So the embedding needed to be same to same, right? So that is why I am again calling the OpenAI embedding to embed my retrieval, question of the retrieval. Okay. Now this is where I am loading my Chroma database. Okay. So as you see, I am specifying my collection name from where I want to get my vector database, what kind of embedding that I am going to use over here, and what is the persistent directory for it. So, and obviously after getting the Chroma database, if you touch this method, it is giving you the Chroma database, the vector database. Okay. Now I am asking the same thing, give me the retrieval of this particular vector database. As simple as that. So I have my retrieval object, right? So let's try to execute the same query. Okay, what is the function in Python? Okay, So you see the result is instantly produces over here. Okay. Now this part we are doing the RAG. Remember, we are already doing the RAG. Okay. Now this is our context. Okay. Now I will create my LLM model. Okay. That's the OpenAI. Chat OpenAI. So my LLM model is ready for me. Okay. Now this is very interesting section. Okay. So if you remember, I have imported this particular LangChain prompt template. So obviously, when we are talking with a large language model, we have to give some input to it that the LLM can understand what is the purpose that we are asking him or it rather to fulfill, right? So that is why we have to give some kind of prompt. Prompt means it's an instruction to the LLM that he can understand. It can understand what is being expected from him in this particular journey. Okay. Now let come down over here. Here is a simple template. As you see, it's a written in a human language. So what exactly we are trying to give the instruction to the LLM that use the following piece of context to answer the question at the end. If you do not know the answer, means the context has not been provided to you, just say that you don't know. Okay. So after writing this, we are passing the context. So the context is our RAG. So this is our template. Okay. From this to this, our template. Okay. Now we are passing this template to the from template function of the prompt template to generate our RAG from our custom template over here. Okay. You can do the similar thing. You don't need to write all the template over here. It is needed for the customization purpose. But of course you can use hub.pool pre-built template also. Okay. Now we are here, we are formatting the doc. It's a very simple function that we need to pass it to the LLM. Now this is important. This is where the power of LangChain really comes pops up. Okay. So what exactly we are doing over here? We are saying that we are creating a chain. Okay. We are saying that as we specify our variable name as context over here, we are supplying the retriever over here, because remember, retriever has the information which we are getting from our vector database, right? So immediately that becomes the input or the context to the LLM model, right? Now we are formatting the docs, means it's a pipeline. So the purpose of this particular signing Python is that it took inputs from the left hand side and pass it to the right hand side, and it goes on. Okay, it's a chain. So whatever the retriever has, it will be passed to this particular format docs to return the output by the function. Okay. Now we are asking the question, it is runnable pass-through, and what is the runnable pass-through? We will discuss in a very different video, because it will take much time to understand this particular runnable pass-through. Okay. For now, you just think as it passes the information from one to another. Okay. So that is the runnable pass-through. Now here we are using our custom prompt template. Okay. Here you are specifying our language model. Okay. So if you remember, I told you that the purpose of this particular pipeline is that it takes the content from the left hand side and passes to the right hand side. Okay. So obviously this will be taken from the left hand side. It will be passed to the RAG, from custom template that we have created. Okay. So obviously, if I supply this particular input, okay, then what will happen? See, here we said context equal to retriever, okay, and question is equal to runnable pass-through. Okay, so it is taking the value from the left hand side and passing to the right hand side of this particular function that we have written. And if you see that you have placeholder, it is the context placeholder, it is the question placeholder. Okay, so that is why the question is coming over here. It's a placeholder. We are passing the question. It will take the value from here and pass it to over here. Okay, and for the context, it will take the value from retriever format docs and pass it to the context over here. Okay, and it will generate us the real-time template with the real-time data, which will be passing through to the right-hand side, means the LLM. Okay. Now the output of the LLM means what the large language model giving us the answer will be parsing through the one particular parser. Okay, that's the whole purpose of this particular section. Now let us run it first. It's compliant, it's done for us. Now we are trying to invoke this particular chain, RAG chain. Okay, so it is runnable, serializable. Okay, so we are going to run the same query. Okay, so you remember the query is over here. What is a function in Python? So we will be running this particular query. We will be passing the query. Again, I am saying the flow is like that. This will be our query. Will be become our question. It will be passed to the template here, and obviously by the query, whatever the retriever is going to retrieve, okay, it will pass as a context to the LLM. So for the LLM, it will be like that. This is the question that the user is asking, and this is the information that we are passing to you. Please answer the question based on this particular context or the answer that we are providing to you. Okay, on a human readable format. So let us execute. So I'm just wanting to see what is the type it is returning. Okay. So as you see, it is returning the str. Why I'm interested for this particular type? If you remember, when we executed this RAG over here, okay, we print out the result, right? If you see, the output was list of document, right? Now, this is the result of the RAG, okay, by the retriever from the vector database. So it's a list of document. Now, when the list of document is passed through the, or passed to the LLM with the output parser, okay, over here, the return type becomes, string, okay. Now you will see what is the output that we are getting back. Okay, so this is the output from the LLM. A function in Python is a name of sequence of statement. It's all being written over here. Okay, now if I can take it in a simple notepad just to show you what has been written by the LLM. Just give me 1 minute. Okay. You see, this is the output from the LLM. So it is much more readable format. And if you remember the output from the RAG itself, if I just put it side by side just to show you, demonstrate you. So you see, this is the output of the RAG, and this is the output of the LLM over here. Okay, I hope it is pretty clear what exactly the large language model is doing over here. Okay, so let us just go to our workbook one more time and just try to see few more things. It's very interesting actually. So if I remove this str parser from here, I don't want to parse the data, the raw data that is returned back from the LLM. Okay, I need to compile it one more time. Okay, let me do it. Okay, now if I just execute this, you see the return type has been changed. Okay, so the raw return of the LLM is not string. Okay, if I type over here, if you remember, this output was a string. Okay, and if I when I remove this particular parcel, the output become LangChain code message AI message. Okay, that is expected because it's a return of the AI, right? Now, if you see the raw result also, you will see how it has been changed actually. So this is the raw output from the LLM. Okay. So you see AI message. This is a indication of that. This is a return back from the AI. Here is the content. Now under the content, all the things has been over here. Okay. Now this is the response metadata part. Means the token uses prompt tokens, how much token. So this is all about the tokens. Okay, and token cost of some money, right? So if you want to see what model has been used, it's a GTP 3.3 3.5 turbo has been used. Okay, so all the metadata associated with the response has been now you can see it. Okay, that is not useful for the end user actually, but if you are a developer, that could be a useful information and information that you could have. Okay, so that is the purpose of this output person. It just gives us a more end user aspect of that by removing all the metadata from here. It's a normal human readable message. Okay. Now let us try to change our question. Let us try to change our question also. Okay. So what is the function in Python that we have asked to the LLM? So can we let's take this particular question also. What is a lambda? Okay. Let's try this particular query over here. Okay. Let's park it. What is lambda function in Python? Okay. Let us see. Yeah. This is the rag output. If I take it to the notepad, you will see what is the output. Okay, let me remove this section for you. Okay, so the question was what is the bag? Okay, this is the output that we are getting. Okay, so it's really very difficult to read actually, but if I just make it readable for you, this is the collection of the document. So here it ends. Okay, this is the first document chunk, this is the second document chunk, this is the third document, this is the third document chunk, and this is the fourth document chunk. Okay, and you can easily convert to it to an array. That is very much possible also. You can convert it to a JSON array. Okay. So as you see, this is the first chunk, this is the second chunk, third and fourth chunk. Okay. This is the output of the raw rag query. Okay. Now if I ask the same question to LLM, means the query has been modified over here, so we don't need to run this particular portion anymore time because it's already ran. Okay, so now if I just ask the LLM the same question, okay, and try to see the result. Oh sorry, I removed the output cursor, right? So I need to. Okay. Now see, this is the output of the LLM. Now if you see side by side actually, if I try to, if I can show you side by side, let's see if I can do it for you. Yeah. So you see, this is the result of the RAG search from the vector database, and when the result of the RAG has been passed to the LLM, this is what the LLM has been responding to us. Okay, it's a more human readable message.